before we even get going, I had a couple typos that I caught after going through. Let's be nicer for the point I'm trying to make there. And then number 2, let's cross out that equation, mostly because we're going to change theta negative into a positive, but taking a positive, make it negative isn't all that clean. Okay, now this is our last transformation, okay, the phase shift. A phase shift is just a fancy name for a horizontal shift. So moving something like log functions, right? We graphed the parent function, and then we shifted it after graphing the parent function either up, down, left, or right based on those transformations. We're going to do the same thing here. So what I want us to do first is we're going to come up with a set of points for the parent function. I'm going to call it over 2 for now. So I'm going to graph sine of theta just like I normally would. So it starts at 0. Period is 2 pi, so I get back to the midline at 2 pi. I'm also on that midline at the half period point. The quarter period is a maximum. The 3/4 period is a minimum. Now I'm not going to connect those dots yet because those are not the dots for the graph that we're actually trying to come up with. We're trying to come up with sine of theta plus pi over 2, where it's been shifted left pi over 2. And that brings up kind of a reminder about these horizontal shifts in that it's the opposite operation from what we see. So if it's theta plus pi over 2, that is actually shifting it left by pi over 2. Right? Positive usually means right, but when it's a horizontal shift, it's the opposite from what we're seeing. So pi over 2 on this graph is 2 squares. So we need to take each point and shift it left by 2 squares. So 2 pi moves over to 3 pi over 2. 3 pi over 2 moves over to pi. Pi moves over to pi over 2. Pi over 2 moves over to 0. And then 0 moves over to negative pi over 2. And so all those points in purple, I didn't pick the best colors to tell the difference from, but are the graph of sine of theta plus pi over 2. And then we can continue adding points into this because I know that I alternate. I went midline, max, midline. The next point at negative pi is a minimum. 3 pi over 2 is a midline. And then 2 pi back to the max. Okay, and there's our transformed function of sine of theta plus pi over 2. Right, why don't you take a second and just do the same thing with number 2. So start by graphing or coming up with points for just regular cosine, and then identify that transformation, and then move all those points. Okay. So in red is the graph of points are on this graph. And then with it being theta minus pi over 2, that's shifting everything to the right by pi over 2. And based on the scaling here, that's right by 2 squares. Okay, so every point getting shifted right by 2 squares. And that's essentially how we're going to graph all of these functions with a horizontal transformation. Okay, we'll start with the function without the phase shift, and then we'll apply the phase shift to come up with the graph. Any questions here before we kind of move on to the next part of this? Okay, so one thing before we kind of move forward with this, and we kind of touched on this with writing equations, but looking at the graphs that we came up with 1 and 2, compare those to the basic functions of f of theta being sine and f of theta being cosine. What do you notice about this graph of purple? What does it look like? Cosine. And that's exactly right. So not only is it the graph of sine of theta plus pi over 2, this equation is equal to g of theta being cosine of theta. Okay, so cosine of theta is equal to sine of theta plus pi over 2.
Whoa, it's not crazy.
No, ain't that something?
And what do we notice about this graph in the red?
Theta, sine theta.
What does this one look like?
Sine.
Looks like a sine, right? Starts at 0, period's 2 pi, and so cosine of theta minus pi over 2 is equal to just sine of theta. Okay, and that's what I meant by when we were going through writing equations, that every sine graph can be written as a cosine and vice versa. You just have to apply the appropriate phase shift.
Why would we learn phase shifts if you could just switch whether it's cosine or sine?
Because sometimes we're not going to see like nice points, so we're not going to see a midline or max or minimum on the y-axis, and so it would be really difficult for us to write the equation without that phase shift. Okay, the phase shift is, yeah, all graphs still have phase shifts, not all, but there still can be phase shifts, and we may not be able to write it just a regular cosine and regular sine function. Okay, so on to the next part, and this is really important for how we're going to deal with functions that have lots of transformations. So the parent function, okay, or our equations with all the transformations look like this. A sine of b theta minus c, or a cosine of b theta minus c. Notice how the b value is factored out of the theta minus c term. Thank you.
About middle names. Huh?
Okay. Notice how the b term is factored out of theta minus c term. Okay, that's something that we're going to have to do. And the reason that we need to do that is that way we can easily identify the period and the phase shift. Okay, because without that, like a lot of us, we're going to see this and say, hey, that's shifted right by pi over 2. But that's not true. That shifting of right of pi over 2 is affected by the phase shift, or excuse me, by the period change. So the first thing we're going to do is let's just practice taking these equations and factoring out this 2 and putting it in this form that we see here. So we're going to take everything in the parentheses here, 2 theta minus pi over 2, and all we're doing is factoring this. And what we're going to factor out is whatever value is in front of theta. We want theta to be a positive 1. Now remember that factoring is just division. So if I want to get theta to be 1, I need to divide both terms by 2. But this 2 doesn't go away. That 2 is essentially our greatest common factor. It obviously doesn't go in the pi over 2 perfectly, but it's still a common factor here. So the 2, I'm going to put in front of the parentheses, so I have 2 times theta. And I need to figure out what pi divided by 2 again is. Well, how we divide fractions, I take my numerator, which is pi over 2, and multiply it by the reciprocal of the denominator, which is 1/2. Making this pi over 4. So this is really theta minus pi over 4. One thing that I suggested to us when we first learned factoring is after you write down your factored form, check it. If you distribute this 2, does it match up with where we started with before? And yes, it absolutely does. Right? That ends up being 2 theta, and then 2 times pi over 4 is 2 pi over 4, which reduces down to pi over 2. So this equation, we're going to use f of theta equaling sine of 2 times theta minus pi over 4, making our horizontal shift right by pi over 4. Okay, I want you all on number 4 here to practice doing the factoring as well. So take that equation, factor out the 2. See how that changes 2 pi over 3 and identify the phase shift.
Rowdy.
I need to divide. Off to the side here, and again, some of us are going to see patterns and just realize that when I take 2 pi divided by 3 and divide that by 2, the denominator of 3 gets multiplied by that 2. So it's 2 pi over 6, which reduces down to pi over 3. So this shift is actually taking our graph left by pi over 3. And not 2 pi over 3. Again, that period change affects the phase shift. Okay. Questions here? I changed these notes up. I don't want to do what I have here at the bottom. So we can just essentially ignore what we're doing there at the bottom. All right? So go ahead and flip this over. And let's start to put this to use. And we're going to graph 3C. We'll come back for 4C. We'll do that tomorrow because that one's going to be a little bit more difficult. Yeah?
Will there be a math
No. Math Excels I'll never do with graphs because it's not the same as actually graphing it. So it's just going to be a paper assignment that you're going to work on in class tomorrow. Okay? All right. First thing we need to do is exactly what we just practiced in getting theta to be 1. So I'm going to divide both of these terms by 2. And by doing that, that makes my equation f of theta equals sine of 2, that would be theta, and then minus pi divided by 4. All right, so here's kind of the main thing that we want to do here. So before we even do that, let's figure out what the period is. So period is 2 pi divided by b, where b is 2, so it's just pi. With all of these graphs that have phase shifts, you're going to be given the graph mostly blank. And what we need to do is decide what we want each little tick marker, each increment to be. You always are going to pick it to be whatever your phase shift is. Okay, so pi over 4. Now, here's where we can kind of give ourselves some space or scrunch it in. I can let every other be pi over 4. As long as I can get to a full period, then I'm going to do that. If I can't use every other as pi over 4 without showing one full period out to positive x, then I'm not going to do that. So let's just make sure. So if I go pi over 4 on the second one, if the next one would be 2 pi over 4, next one would be 3 pi over 4, last one is 4 pi over 4, which is pi. So let's do that. Let's make every other one of these pi over 4. 2 pi over 4 is actually pi over 2, then 3 pi over 4, and then 4 pi over 4, which is pi. We're going to label that same thing off to the left. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. All right, and then we're going to graph, we're going to start with sine of 2 theta without the phase shift. So I'm going to start with sine of 2 theta. And then we'll come back and shift every point to the right by pi over 4. So sine of 2 theta, I know sine starts at the midline, which right here is still the x-axis. We have not shifted the midline. I know I get back to that same point at a distance of pi. My half period is pi over 2. And I have a maximum at pi over 4, minimum at 3 pi over 4. And now using those points, I'm now going to apply the phase shift, which is taking everything right by pi over 4, which is 2 squares. Right? Every other was pi over 4. So I'm going to take each point and go right by pi over 4. And then I'm just going to continue the pattern to get another cycle heading towards where x is negative. Okay, so every 2, now I should be at a minimum, back to midline, maximum, midline, minimum.
So the 2, it doesn't matter, the one next to between the sine and the...
It does. That 2 is what changed our period from 2 pi to be just pi.
Yeah, and once you get the period, it doesn't matter.
Yeah, that's all it does is affects the period. Once we're done with the period, it's all good. What does this graph kind of look like?
Cosine.
It looks like a cosine, right? This is equal to cosine of 2 theta. Okay. We're going to stop there for today.